Hello, and welcome to this quick take video describing the different types of projects and use models available in the Vivado Design Suite. We realize that not everyone uses the tool in the same way. So to provide flexibility, the Vivado Design Suite has different types of projects for different use models. The first one, RTL project, is for the people that want to drive their entire design from RTL and IP all the way through synthesis and implementation, bitstream, and into hardware validation. The tool supports that entire flow from front to back. You can also use that same project to create a standalone IP module. You can use the IP catalog to configure and implement an IP, and you can run it through synthesis, implementation, and logic simulation, all to validate it. You can also open up an empty project just to perform device exploration and examine device resources for the various types of architectures and devices. The next project is a post-synthesis project. This is where you're going to import synthesized Netlist as a source for implementation and analysis. This is common when using third-party synthesis tools. We also enable an I/O pin planning project. This is an empty project that enables you to start early before you might have Netlist or compiled RTL to create your I/O assignments. You can either create ports manually on the fly, or you can import them from a CSV spreadsheet, an RTL header, or an XDC file. And after you're done with your assignments, you can migrate this project to an RTL project if you wanted to move the assignments forward, or you could export them and import them into a new project. And the last one is an imported project. This is to help users migrate from either Simplify, XST, or an ISE Project Navigator project into Vivado. It imports the sources in compilation order only. This is intended for people that want to move forward with this design in the Vivado design environment. So no synthesis or implementation results are imported. The assumption is that you're going to rerun them in Vivado. And no tool settings are migrated. Since the Vivado and ISE tools are not really compatible as far as tool settings goes, we've elected not to try to make that migration for you. Now we'll walk through the process of creating each one of these types of projects. When the Vivado IDE is invoked, the Getting Started page is displayed, allowing you to open previous projects, view documentation and quick take videos, as well as create new projects. We'll select the Create New Project link. The next page allows me to enter a project name and location, as well as be able to select whether I want to create a project subdirectory with the project name as the title. So this way all of my project is under a subdirectory underneath the project location I've defined here. The next panel is when I define the project type. Here are the types of projects we just went through in the slide: the RTL project, post-synthesis project, I/O planning project, and imported project. And I'll select RTL project. Notice I do have the option to not specify any sources at this time, and I could do device exploration inside of an RTL project and then add sources later. I can also use this option if I wanted to generate standalone IP. I can open an empty project and use the IP catalog to configure, implement, and validate the IP, and then I could import that IP into future projects. And the next window is the Add Sources window. This allows me to select the other individual files or directories, or create files. Notice here I have the option to create a new source file, and I can enter the specifics of the file here. I can use the Add Directories command to add all of the files that Vivado deems as sources into the project that are included in that directory or any of its subdirectories. Notice in the Add Sources window here, I can elect to change the library for all of the files that are included in the bftlib directory here. And this is how I can set my VHDL libraries for VHDL files and so forth. Individual files can also be selected and imported using the Add Files command. And notice here again, once they're imported, I can elect to change the properties of those files in the window before import. Notice here I'll select the test bench and designate it as a simulation-only source so that it'll end up in the simulation set in the Vivado sources window. There are also some other options to control how these files are imported. Notice at the bottom here I can elect to scan and add any of the RTL include files that may be referenced by RTL files in my design. I can elect to copy the sources from their original location into the project directory and have a resident sandbox or a resident set of files that I would work on with the project. If I unclick this box, the Vivado project will recognize the sources in their original locations and keep track of them as far as if any of them get updated, the design status will be affected accordingly. And the last one here is to add sources from subdirectories. If I select a directory for import, it's going to scan that whole directory as well as all of the subdirectories beneath it for any files that Vivado deems as sources. I can also set the target language for the project, and that's when I create IP, do I want the target language to be in Verilog or VHDL. And notice I can also control the order in which the files are imported and processed by using the arrows on the right side here. And the X button is remove, which will remove the source file from the list of files to be imported. And the next window is the Add Configurable IP window, which will allow me to select either core generator or Vivado IP, and they're distinguished by either the .xco for core generator and .xci for Vivado IP. Adding Vivado IP will either use the RTL that's in the IP project directory, or if you've synthesized it, it will use the netlist. And notice I have the same option to either copy the source files into the project or reference the IP remotely. The next window allows me to add XDC or SDC constraint files into the project. Notice I can create files here as well. And I can select different files and view them in the viewer. And notice I've got a BFT full XDC, which has all the I/O constraints defined, and just a BFT XDC file, which is simply timing constraints. I'll select the full version. And notice I've got the same controls to control the order of the XDC files if I have multiple files, as well as the ability to copy the constraint files into the project or use remote constraint files. The next window allows me to select the default part for the project, and I'll pick a Kintex 770T device. Notice that all the information about the part, including the device utilization resources and so forth, are displayed in the chart. I can use the filters above to filter or search the list so I can more easily select the part. And the last window is the new project summary, detailing the selections I've made to create the project. Notice now that as the sources are being imported and configured, the hierarchy is automatically being sorted and compiled so that it can be displayed in the sources view. Once that's completed, notice the sources are all displayed in the sources view. I've got access to all the Verilog and VHDL files in the order they'd be compiled in the design, as well as the IP. The constraints, notice I've got one constraint set with the file we imported. I could create multiple constraint sets if I wanted to in the project. And then the simulation sources. I can see the test bench source file displayed under SimSet 1. Now that the project is fully loaded into the Vivado interactive design environment, I can use the Flow Navigator as well as all the other capabilities of the Vivado IDE to drive my design all the way through hardware validation. So that's the process for creating an RTL project. Now let's walk through the steps to create a post-synthesis netlist project. I have the same initial window asking me for a project name and location. I'll now select the post-synthesis project type to create. I can then add files or directories which might contain netlists. Notice that when I use the Add Files button, I have a filtered list of the types of files that Vivado recognizes as netlist-based sources. I'll select the top.edif file and import it into the project. Notice how the sources table allows me to define a top edif module. If I had more than one netlist, I can specify which one of the netlists contains the top-level module so that the design will compile properly. I have the same capability to either copy the netlist sources into the project directory or use remote sources, as well as the recursive or non-recursive search down through the directories for sources. If I use the Add Directories button, Vivado will look for all of those source types that it deems as netlist sources and will import them into the project. The next window allows me to add SDC or XDC constraint files. Notice I was not presented with the ability to add IP into a synthesized project. This project type is expecting synthesized netlists, which I could easily extract from the IP directory. I'll select the BFT full.xdc again and select the default part, and the project gets created. Notice that with a post-synthesis design, I'm not presented with certain steps in the Flow Navigator for RTL source control and IP generation. I can open the synthesized netlist for design analysis and constraint assignment and use the Flow Navigator to process the design all the way through hardware validation. So that's the process for creating a post-synthesis netlist-based project. Now let's walk through creating an I/O planning project. I'll again give it a name and location, as well as select the I/O planning project type. And now notice I'm presented with a window that allows me to select either a CSV spreadsheet for import or an XDC file. Or I can elect to not import sources at this time and to create ports on the fly or do device exploration. You can refer to the Vivado Design Suite user guide under I/O planning for more information about the CSV spreadsheet formats. And I'll select the existing CSV spreadsheet here. I'm then asked to select the default part and click through the summary, and the I/O planning project is created. Notice that I can see the I/O ports that have been defined in the spreadsheet placed in the package view. I've got access to the I/O ports view, which gives me all the information about the I/O ports. And notice the Flow Navigator is an abbreviated version with the only commands available being for I/O planning and validation. So that's the process for creating an I/O pin planning project. Now let's walk through the process to create an imported project. I'll again define a name and project location. I'll select the imported project type. And then notice I'm presented with a menu of which type of project I'd like to import. In this example, I'll select ISE and browse to find an existing ISE example design to import into Vivado. Notice again I'm presented with the option to copy sources into the project directory or use the original sources in the ISE Project Navigator project directory. All of the source files and order of the source files is extracted, and the hierarchy is displayed for me in the sources view. There is an ISE import log. If there were any issues with any of the files during import, you'd see details about it in this file. Notice that when I expand the sources in the sources view, I've got all the sources in the correct order that were imported from the ISE project. Since UCF constraint format is not supported in Vivado, the constraint files were not imported. However, for logic simulation, the simulation set and test bench were imported, as you see here. It's always a very good idea to examine the ISE import log for any issues or problems with the import. I can then use all of the features of the Vivado design environment to process the design through bitstream and hardware validation. So that's the process for creating an imported design using an ISE project. It's very similar for creating a Simplify or XSC project, so we won't bother going through that. So in summary, the Vivado interactive design environment provides flexibility in how you use the tool in your flow. You can start with RTL, IP, third-party synthesized netlists. You can do your system assembly and integration within the Vivado design environment, and then either synthesize and implement the design all the way through hardware validation. You can create and validate standalone IP and then reuse that IP in other projects. You can perform early device exploration or I/O pin planning by using an I/O pin planning project. And to save work in gathering source files and ordering source files, you can import existing projects from either Simplify, XST, or ISE. So as you can see, the various Vivado project types provide the flexibility required to support different types of users and different type of use models. For more information, please refer to the Vivado user guide, Vivado tutorials, or quick take video demonstrations related to design flows and project features. Thank you very much for your time.